This is our application, the TA Efficiency Program, an optimization model that will help determine the optimal number of TAs a professor should hire, and then determine the best schedules for TAs to host office hours. In the first part of the model, we have a user-friendly form in which the professors can input the necessary data to help the tool optimize the number of TAs they should hire. The information that will be inputted under the course info is ultimately going to become a part of the constraints for our solver model for optimization. Also, notice that as you type into the boxes, a helpful note appears to clarify what data to input. The information under grade requirements for TAs are grade qualifications that the professors decide they want their TAs to meet. After filling out all the information, the tool is ready to optimize the number of TAs this professor should hire. Clicking on this button that says, "How many TAs should I have?" will prompt the professor to supply more data on the capacity of each TA for each category of his or her duties, such as grading exams, assignments, quizzes, and others. It is up to the professor's discretion to quantify the capacity of each TA, according to the difficulty level of the exams and assignments. The higher the difficulty level, the lower the TA capacity. After filling out all the form, Solver will run and return the optimum number of TAs this professor should hire for the specific course he provided information for. In addition, we added a helpful component to this tool that generates the top recommended candidates for TAs. This button runs Excel to filter out qualified students for the TA position from the student statistic information sheet that we simulated. This sheet takes the TA qualifications that the professor inputted in the user form initially and assesses the students to find the ones who meet all the requirements specified by the professor. Then, the model outputs all the names of the recommended top TA candidates. This bonus component of this optimization tool is intended to assist the professors in seeking out which students to ask to be their TAs. And now, by clicking on this button, would you like to optimize your TA schedules? We move into the second part of our tool. After coming up with the recorded number of TAs and the top TA candidate list from the first part of our model, our second part of the model will generate optimal office hour schedules for each TA, which maximize the number of students who can come to the TA office hours. This model is very user-friendly. There are only a few inputs the professor will need. The first one is the number of TAs the professor will actually have for the class, which does not necessarily have to be our recommended number from the last part of the model. From this simulation, the recommended number of TAs is 8. Let's say the professor decides to actually hire 6 TAs. The second input is the class size, and the third input is the student to TA ratio, which is essentially how many students the professor thinks one TA can accommodate during the office hour. In addition to these, the professor will also need schedules from both the students and TAs. For our simulation purposes, we are going to generate some random schedules. So we hit this button, and as you can see, these are all weekly schedules, and for each day there are 1-hour time slots between 8 a.m. and 8 p.m. The numbers for the student's schedule indicate the number of students who can come to this certain time slot for TA office hours. And on the TA schedules, 1 indicates that the TA is available, and 0 means a TA cannot make this time. Each TA can also indicate the number of hours they are willing to work per week. In real life, the professor will collect data from both the student body and each TA at the beginning of the semester. After they input everything, we can hit the Generate TA Optimal Schedule button and wait for the solvers in the back to run. While waiting for Solver, we'll explain briefly how the algorithm works. It is basically a combination of VBA and optimization tool solver. We use Solver to generate the optimal schedule for the first TA, having the schedules as decision variables, the number of scores of available students as objective function, and the number of hours this TA works per week as a constraint. After running the solver for the first TA, we update the student's schedule accordingly, and then run solver again for the second TA. The for loop in the VBA allows us to run this process repeatedly and come up with optimal schedules for each TA. So now, the solver finishes running, and you can see the schedules our model generates for each TA. The highlighted cells indicate the time slots this TA is going to host office hours. With this model, professors at any department can easily come up with the schedules that maximize the interaction time between TAs and students. And that's all for our simulation.